Hello, everyone. I'm Valerie Cushman, Senior Director of Alumni Initiatives and Alumni Engagement and Inclusion Initiatives at William & Mary. And I'm really thankful that you are all able to join us today in our first edition of our STEAM series, specifically Women in STEAM series. So science, technology, engineering, arts, and mathematics. So we'll be having 4 programs throughout the coming months between now and December, and I'll talk a little bit more about them. But we're launching it today with partnering with our VIMS faculty and staff. So I do not want to take a lot of time today because we have a really interesting program that I had a chance to have a quick preview of late last week. So I would like to introduce to you Molly Mitchell, who is a research assistant professor at VIMS, and Sally Brooks, who's the Assistant Director of Advancement and Outreach at VIMS. And they are going to navigate us, and I use that term intentionally, through this topic of rising tides and sinking coasts. So with that, thank you everyone for joining us. We'll look forward to actively using the chat. So please use the chat for emphasizing something that catches your attention, for posing a question, for helping us to illuminate the topic from your various perspectives as well. So the format will be, we'll have about 25 minutes or so of a presentation, and it's an engaged presentation, so no sitting in the back of the classroom for this one. We'll be asking you to pull out your cell phones and participating actively in Molly's presentation. And then we'll open it for Q&A. And then we'll also go to breakout sessions where we can all engage around the topic and share insights about what we've learned in our own personal experiences. So with that, I say great thanks to Molly and Sally for partnering with us, and for the Society of 1918 for helping to bring these kinds of engagement opportunities for William & Mary women. Molly and Sally, it's all yours.
All right, thank you, Valerie. I'm really honored to be the beginning of this STEM series, or STEAM series. That's right, we've got arts in there too. I'm a 3 times graduate of the College of William & Mary. So, you know, when you find something good, you stick with it. So I'm a big believer in the college, and I'm excited to be here talking to all of you. So today I'm gonna talk about sea level rise, and broadly how it's impacting the United States, particularly a focus on Virginia, because that's where I do a lot of my advisory work. But one of the things we're gonna do, when I go and I give a speech or a talk in person, I like to actually get some information from the audience and understand where they're coming from. And that's more challenging, of course, with doing everything over Zoom. So one of the things we're going to use, let me get my slides to advance. Okay, so this is a program called Mendimeter, which is similar to a lot of what the faculty are using to teach classes at William & Mary now. And so what you can do is if you go on your phone to mendimeter.com, or you can use an iPad, you actually can use your computer, but you have to toggle back and forth between the screens. And you put that code there, it will allow you to answer these questions. And so we're just starting off with this broad question so that you guys can experience the technology and try it. And what's going to happen is it will develop a word cloud based on the answers that you put in. So this is a really great collection of words. These are some of the things I really appreciated about William & Mary too. Particularly the community part, but also, I mean, I really got an amazing education at William & Mary. The professors are so committed and really creative and put a lot of work into it. So I really did love this part. So I'm going to move on, and I'm going to tell you some of the things that I really enjoyed about VIMS, and this is why I went there for both my master's and my PhD, but I also work there now, the reasons I stayed. Okay, so this is the Virginia Institute of Marine Science. It's located across the river from Yorktown. So if you go down the Colonial Parkway from Williamsburg and then you go across the bridge in Yorktown, you get to Gloucester Point, which is where our campus is located. It's a beautiful area, lots of dolphins come by. It's really a gorgeous place to work. We're actually one of the largest marine research centers. Most of the marine science centers are actually small satellite campuses off of a main campus. VIMS has close to 500 people working there, and at any given time we have about 100 or 120 students. So we're actually quite a large campus, which also gives us a lot of resources that we can use. There's a lot of really good research that goes on at VIMS. We are part of the College of William and Mary. We started as a institute that was funded by the state to give the state advice on marine resources. And we grew over time. At that time, although there were graduate students, they did not get a degree from VIMS. They got a degree from other affiliated universities such as UVA. But then in the 1970s, we joined with William and Mary and we became the School of Marine Science. So now all of our graduates get their degree from William and Mary. And in addition, one of the things that's new since I did my undergraduate is that we now have an undergraduate marine science program. And so we're starting to bring the marine science into the main campus, which is a great collaboration. So our mission, like I said, we were really created to give advice to the state on marine resources. So although we do cutting edge and global research in all areas like Antarctica or the South Pacific or those kind of things, our mission to give advice, to like translate our science into advisory work is very, very strong at VIMS. And this is one of the reasons that I actually stayed there. As far as I know, this relationship is unique among states and universities. So many universities will give their states advice, but the states may or may not want to take it. Whereas in Virginia, the state will actually come to us and ask us questions about the marine resources. And then when we give them back answers, there's a lot of buy-in because it was solicited by the state. I mean, so this is their research basically to help them. And then I do a lot of work. Sea level rise and marshes are the two pieces which I do a lot of advisory work for the state. And this is a beautiful marsh located in James City County. And then, of course, one of our other roles is education, and it's both education of graduate students. We have undergraduate education that we do. We also have a pretty big K through 12 outreach program that both goes into the schools and also does summer camp outreach. And then we do a lot of community speaking. So I've gone out to lots of different groups, and it's just people who are interested. It's not necessarily people who have a stake in something. So I've talked to, I've given talks up on Capitol Hill to legislators who do have, you know, a decision-making thing, but I also give talks to the local Kiwanis Club or at local churches, just for people who are interested in learning more about marine science. Okay, so we're gonna try another question. I actually have a couple of questions in a row, just to get some background about you guys. And so I'm curious to know with the people here what coasts you live on. Okay, so we seem like we've kind of stopped getting answers. So I'm going to move on to the next question, which is, how concerned are you personally about sea level rise? And so the one thing this is going to do is it's going to split your answers. You can tell by the colored dots by how you answered the previous question. So depending on what coast you live on, you might be more or less concerned about it. Okay, so this is great. It looks like a lot of people are concerned about it. I am concerned about it too from a state and a national perspective. I will say that from a personal perspective, I don't live anywhere near the water. So, you know, it's not gonna affect me personally. Okay, so the next question I asked is, have you personally experienced flooding? As I said, I do not live near the water, but actually I did lose both of my cars one night in a flood that was precipitation driven. It wasn't sea level rise. But that definitely colored my view of the issues with flooding. And so I think more and more people in the Virginia area are starting to experience flooding, but this is true on some of the other coasts and things as well. So it looks like this group is almost perfectly split between having experienced flooding and not. So thank you all. That helps me get some ideas of where you all are coming from. Okay, so now I'm going to tell you why we're so concerned about it in Virginia. The General Assembly did come to VIMS back in 2012, and they asked us about sea level rise and if we could tell them how much of a problem it was and what they could do about it. And so a lot of my research came out of that question, and I'm going to share some of that with you today. So this is a street down in Norfolk, and you can see this is actually during rush hour. You can see there's a little bit of water on the street, and in Norfolk, which is a very low-lying city, they've seen the hours of flooding since the 1970s has increased by 577%. So there's been a huge increase in the impact of flooding. And this is a problem because you can see all these neighborhoods here that are built and the roads in areas that do flood routinely now. And the problem was we didn't know they were gonna flood. We didn't really have a good sense of this, and I'm gonna show you why. So this is a graph of the hours of flooding per year, okay, from 1928, and right now it's going through 1960. And so if you're in 1960 and you're making a decision about where you're going to invest in your new city center, you want it waterfront, you want to be able to have people come down and enjoy the waterfront. It connects to a harbor, which is great. And so if you're looking in the downtown Norfolk area, what you see is that at that time, we had, 2 years in that entire time where then been more than 2 days of flooding. Okay, but that's really not that much. So even in those years with a lot of flooding, there's, 363 days where there's no problem getting to and from the city center. And most of the years had very little flooding. Okay, so if we move to 1985, what we see is, so these years with 2 days, greater than 2 days of flooding are occurring a little more frequently. The average has gone up slightly, so we're at 1.7 days of flooding a year. Still, that's not much. And then we have this 1 year, 1983, the one with a red arrow to it. And that year we had over 3 days of flooding. Okay, but that was just 1 year. So does this still seem like a good investment? I mean, I would say yeah, because we have a little more flooding maybe, but it's increasing at a relatively slow pace. The problem is when we extend this series out to today, that red arrow is pointing to 1983, which was the year that had the most flooding in that original series. But now you can see that actually looks like a pretty good year. So we're getting a lot more flooding, but this was not particularly predictable from that early part of the series. We weren't really expecting to see this. We were expecting to see a much flatter, we knew sea level was rising, but we were expecting to see a much flatter trajectory. Okay, so what's going on with sea level rise? I mentioned we knew it was coming up. So we've been measuring sea level since the 1950s about in the major harbors around the world. And as long as we've been measuring it in the Atlantic Ocean, it's been coming up. So our record in Norfolk goes back to 1928. So we have about 100 years of data on sea level rise from tide gauges in harbors. But that only tells us what's happening at the land. In 1992, we started to put up satellites, and these satellites measure satellite altimetry, is a measurement of the entire surface of the water. So this is a much shorter record because it's only since 1992, but it is a global record of how water levels are changing. So when we bring the two together, we can then make a map of how sea level's been changing around the world. And so our mean sea level trend globally is about 3.2 millimeters a year, which doesn't seem like a lot, but it does start to add up. But one of the important things I want to point out on this globe here is you can see there are some dark red areas where sea level is coming up 8 to 10 millimeters a year. So it's coming up quite a bit faster than the global average. And then there's some light blue areas where sea level is actually falling about 2 millimeters a year. So much lower than the global average. So this average is, you know, the whole experience of the globe brought together, but it's not what's happening at any given point. And in Virginia, we actually have much higher sea level rise than that global average. Okay, so what's driving global sea level rise? There are two big processes that are driving it. And one of them is called steric changes. And steric changes are when water heats up, the molecules in the water start to move faster. And that actually, they take up more room. And so the water expands. And the best way I can tell you to think about this is the same principle a pressure cooker works on, except with a pressure cooker, we're containing them so the water can't take up more space. But in the ocean, the water expands out onto the land. The other process is eustatic. And this is the melting ice sheets. This is the one you hear about the most if you hear news articles or that kind of thing. So this is when ice sheets on land melt, but it can also be from when we take water out of underground aquifers and then we use that water. We usually release it back to a creek, which eventually empties into the ocean. So it can also be water taken from freshwater storage on Earth and released into the ocean. So these are the two things that are kind of that global driver of that 3.2 millimeters a year of rise. Okay, but if we look around the United States, this is a sea level rise report card page. And so one of the things I do is every January, I get tide gauge data from all of these 32 tide gauges, and I calculate the trends and the patterns of sea level rise and acceleration around the country. And what we can see is that this, in the Gulf, in Louisiana and Texas, this is where we have the highest rates of sea level rise. So 6 to 7 millimeters a year, almost 8 millimeters a year in Grand Isle, Louisiana, coming up. The next highest, though, is actually Norfolk, Virginia. So we're at 5.14 millimeters a year of rise. So not quite twice the global average, but getting there. But there is a lot of differences around the coast. So if we look up in Alaska, we can see that sea level at these stations is falling relative to the land. And the reason is that there's a little bit of ocean dynamics causing water levels to change, but a lot of what's happening here is tectonic uplift. And so the land is actually moving upwards from tectonic processes. We don't have tectonic uplift, but in both the Gulf and in Norfolk, what we have is the opposite. We have land sinking, so we have subsidence, and that's contributing to our sea level rise. And there's two things that are driving this process. The kind of slow one that we can't do anything about is called glacial isostatic adjustment. And what happens is back in the last ice age, the whole northern part of our continent was covered with these big glaciers, and they weighed a lot. And so they pressed down the surface of the Earth. And because we're a single continental plate, this caused a bulge. And so where this 4 bulges, imagine that's Virginia, it's bulging up out of the sea. And so sea level fell relative to the land at that time. As that ice sheet melted and the pressure was released, the land up in the northern part of the continent rebounded. And Virginia consequently went down. And this is still happening today. We're still sinking very slowly in response to this isostatic adjustment. So we can't do anything about that, but it's important to know that it's happening. The other process that's happening is subsidence due to groundwater withdrawal. So we have 2 hotspots of subsidence in Virginia. One's at West Point, which is where the paper mill is, and then one's at Franklin, which is where there's a pulp mill. And they withdraw a lot of water out of the aquifer. That water is taking up space in the layers of the earth, and as it's removed, the earth above settles down, and so there's sinking that occurs with it. This is actually the same process that was the big driver of those high rates in the Gulf. So the Gulf, there's been a lot of both groundwater withdrawal and also hydrocarbon withdrawal, and that's caused a lot of subsidence in those areas. Now, one of the other processes we have, which is kind of unique to the South Atlantic, Mid-Atlantic, South Atlantic, is this slowing of a circulation pattern called the Atlantic meridial overturning circulation. And you can see on the globe here this pattern, and what it is the water heats up in the tropics, and then it circles up through the Atlantic Ocean. It gets up into the Arctic, where it cools. Cold water is denser, so it sinks, and then it returns to the tropics on the bottom of the ocean. And so this is called the conveyor belt, and this water just constantly circulates. But one of the things that's been happening is it has been slowing down. The entire cycle has been slowing down. The part of it that we're concerned about is the Gulf Stream, which comes right off the coast of the mouth of the Chesapeake Bay. And in the past few years, it has moved offshore. And as it's moved offshore, it has slowed down too. Okay, so both of these things have happened. It's changed the distribution of the water. Okay, so what I want you to think about, and then we'll get back to the diagram, is in the morning, you're stirring your cup of coffee. And if you stir really slowly, nothing much happens. But if you stir really, really quickly, you set up this gradient where the coffee in the center of the cup is dipping down and the coffee on the outside of the cup is higher. There's a little like whirlpool in the center that's lower. Okay, and so the ocean's not a coffee cup, but the concept that fast moving water carries this gradient with it is actually very similar. So what's happened is when the Gulf Stream was moving very, very quickly, it actually pulled water offshore. And so the water level was lower. As it slowed down and relaxed, like you're stirring that coffee more slowly, the water is becoming flatter. The surface of the water is becoming flatter. And so the water is higher on our shoreline. Okay, and so this is a graph of tide gauge data from Norfolk, Virginia. And this is out of a sea level rise report cards. And I just want to show you what the trends have been and then how we use this to project sea level rise. So the lines with the blue dots are our monthly mean sea level that's been recorded at the gauge. This blue line is a decadal trend. So it's a sort of rolling average of what those measurements have been, to get rid of, like, it gets rid of hurricanes and things like that, you know, weird fluctuations that aren't sea level driven. The orange line coming off here is the accelerating trend coming from the sea level, okay? And so what this is I said right now, this is about 5.7 millimeters a year. The important thing about it is it's accelerating, okay? So by 2050, it will be coming up about 10 millimeters a year. So every year it comes up a little bit faster than it did the year before. And what that brings us to is a projection for 2050 of a little less than 2 feet of sea level rise in Norfolk. And this is, in some parts of Virginia where we have higher elevation land, this is not a big deal. Some places where we have most of our elevations are under 8 feet, 2 feet of sea level rise can be a significant impact. Now, the one thing I do want to point out is you see this trend here, this decadal trend, and you can see that sea level goes up and down over time around that orange mean line, that average line. And so these are sort of semi-predictable fluctuations that are due to the angle of the sun and the moon in relationship to each other, and also things like El Nino, La Nina events. And so that is going to keep happening in the future. It's hard to predict where it will be in a given year, but these two dotted orange lines are the boundaries. So this is as high as we would expect it to be. And this is as low as we would expect it to be. And then this is the average water level we would expect. Okay, and then if we want to move out beyond 2050, we need to move away from tide gauge data and we need to move into global climate models. I don't do that, so these are NOAA's global climate models. But the reason we need to do that when we get out into the future is because so many things can change out in the future. We can change the rate at which we're warming, the ice sheets could melt faster or slower than we expected. And in order to incorporate those changes into the trend, you have to actually use a model where you can alter the rates at which things occur. So this is Norfolk, and this is the intermediate curve, which is the most similar to what we're experiencing right now. So that's about about 4 feet of sea level rise expected by 2100. You can see this is our worst case scenario. This is the ice sheets are melting really, really fast. The temperature is coming up really, really fast. We'd expect to see as much as 11 feet of sea level rise by 2100. Now, this is a lot of variation between the scenario most similar to what we're experiencing now and the highest potential scenario. And this is where planning gets really, really difficult. And so I'm going to show you an example here. So this is Gloucester County, Virginia. And if you look at the graph, there's this orange box here, okay, which is the distance between the lowest curve and the highest curve. So these are bounding the possibilities. And if we look on this map here, this orange is the same. So this orange area is the area which could be underwater in 2050, 2040 in this case, or might not be underwater in 2040, depending on which scenario is the one that actually happens. You can see in 2040, it's not a lot of land. We can probably plan around this. We can probably make good decisions about what we're gonna do with the surrounding landscape. When we move to 2080 though, this is a much bigger range that we're looking at. So it's the same thing when you look at the map, the blue areas are the areas that we know will be underwater. Okay, under any scenario, these will be underwater. But the orange areas are the areas where we don't know. It depends on which scenario is most similar to their future. So it could be underwater and it could not be underwater. And so you can see now we're starting to talk about significant amounts of land. And so this brings up really important questions about, do we take the really safe road and not develop any of that land and give up the economic opportunities on it? Or do we go ahead and develop that land knowing that at some point we might run into problems where we either have to retreat from the land or we have to protect it in some way? Okay, because I can't see your faces and I can't tell if you all are horribly confused or if I'm making sense to you, I'm just gonna take a couple of questions before we move on to talking about adaptation. So I'm just gonna take 2 or 3, but if you have a question, go ahead and type it in. Why should you care? Yeah. So if you live on the water, of course you care because it's impacting you personally. But actually our economies in this country are very much tied to our ports in a lot of ways, particularly through the military and that kind of thing. So whenever you have an impact, then you find yourself having these repercussions like going all the way through. So there's a question here about current strategies to mitigate sea level rise, and that's a great question because we are just about to talk about that. And then there was also a question about nuisance flooding versus underwater. So that's a good point. So nuisance flooding is, like I was talking about, a couple hours of flooding. When I said there was 2 hours of flooding a day, I really meant that, you know, over the course of a month, there might have been a couple hours every day. That's what we consider nuisance flooding. It's a low cost event usually. Usually it just means you can't get to work. However, okay, it gets into people's basements, and their basements start to grow mold. It starts to cut off economic opportunities. So nuisance flooding, although we call it a nuisance, can actually be more than just a nuisance. How's the Commonwealth responding to our research findings? Virginia has been, I'm very impressed by Virginia. They have been very proactive. Both the House and the state Senate have been looking at these issues and talking about them. There have been all kinds of efforts to find ways to fund adaptation efforts. The governor's office has been very involved in trying to address sea level rise. So I actually think that Virginia is one of the more proactive states, honestly. Is any of this reversible? Yeah, so that's a really good question. So the first projection I showed you out to 2050 is probably not reversible. Now, it could be that if we actually manage to slow down the amount of subsidence due to groundwater withdrawal, we might be able to reduce that projection a little bit, not much. Now, one of the reasons the global climate models, we have all these different things going out to 2100, all these different scenarios, is that those are based on the idea that making different decisions can lead to different outcomes. So those are based on the idea that if we can slow global warming, so they're carbon emissions, the global climate models are carbon emission based. And so if we can slow global warming, or if we can slow the rate at which ice sheets are melting, then we can have a lower scenario as an outcome instead of one of the higher ones. All right, I'm gonna take one more question and then we'll move on, but we're gonna have more chance for questions and talking. Did Chesapeake Bay impact crater impact land subsidence in this area of Virginia? This is a really interesting question because I know people on both sides of this argument. What it definitely did do was it fractured the land around the outside of the Bay crater. And so those fractures are still slipping, okay? So there's definitely parts of the landscape that are responding to this Chesapeake Bay impact from the meteor. The extent to which it's contributing to sea level rise, it's probably very small because these slippages are very localized effects. So it certainly might be affecting someone's, there are some interesting things with wells becoming salinized, where two people next to each other, one person's well will become saline and the other person's won't. And that's probably because of the slippage of one of these faults. And so that's where you're getting these very local impacts. But when we look at it on a statewide basis, it's probably not contributing much. All right, so now I'm going to talk about adaptation. And there's two ways to look at this, and these are both really important issues. One is, what do individuals need to know? What do you need to know to make a good decision? And the other one is, what do localities need to know to make good decisions? And those are really different pieces of information. So individuals need to know, is their house going to flood? Should they get flood insurance? Is there a better, cheaper way to get flood insurance? Should they find a new route to work because they're going to have a detour every fourth day? Okay, so those are what individuals want to know. And localities want to know what rate of sea level rise they should use for planning. What of their current infrastructure is going to be impacted by flooding in the future? What are their neighbors doing about these impacts? So sometimes we want to be better than our neighbor localities. Sometimes we want to just, walk the line with them. And then the big one actually is, what legal authorities do we have with future flooding? And I'm not going to talk about this today, but we partner with the Virginia Coastal Policy Center at the law school at William and Mary. And they do a lot of addressing this particular issue. So what are the legal authorities and the legal roadblocks to dealing with sea level rise and future flooding? So I recommend you take a look at their website. Really neat stuff. And so when I try to address these issues in an advisory capacity, the important thing to me is that different people and different localities have different personal risk tolerances. Okay, so they're not all going to make the same decision. That's not my first point. But if they have good data and good information and they all have the same information, then they can make better decisions because they're working from the same playbook. So that's our goal, is to get them that good data, that good information. So I'm curious with you all, if you can just rank the most important issues to you. Is it about flooding in or around your house in the next few days? Is it about flooding in or around your house 20 years from now? Is it about what's happening to state assets, how we're spending our state and protecting our state assets? About the cost of flooding to taxpayers? Or if it's about impacts to more of your national assets, so impacts to the military and the supply chains and that kind of thing. We are going to talk about all of these, but I'll spend a little more time on anything that's particularly interesting to you. Okay, so I can see you all are in general big picture people. So we will we'll spend a little more time talking about the big picture, but I am going to show you some tools for the individual too. Okay, so all of the things I'm going to show you can be found on this website that we've put together in collaboration with the Virginia Coastal Policy Center at William & Mary and the School of Economics and Public Policy at William & Mary. And it's called AdaptVA, and you can get there with either adaptva.org or adaptva.com. And this is where we put all the data and all the tools that we think individuals and localities need to adapt. Okay, and so I mentioned the report cards. The report cards can be found on AdaptVA through the tool or through the forecast category, except there's one exception. And so there is 32 stations around the United States that are have sea level rise report cards. But we also have a bay specific one. There's 5 stations around the Chesapeake Bay, and that is actually at a different website, and it's not linked through. So I just wanted to mention that. If you go to VIMS and you search for Bay report card, it will come up. I said that I would tell you about individual. Okay, so this is Tidewatch Maps and Tidewatch Charts, our 36-hour water forecast projections. So you can see on the map in the next 36 hours how the water is supposed to rise and fall across the landscape. So this is that question of what's going to happen to my house in the next 36 hours, you know, particularly when a tropical storm is coming through. These can also be accessed through AdaptVA, but they're on another place on the website too. And so also into the forecast page. Okay, so across the bottom in red now, you're gonna see the actual like links that you can get, take to get there. And I should mention, I do have these all compiled into a sheet. So I'm happy to send that to Val and she can send it out to everybody if they'd like. So this is the question of, should I get flood insurance? This was collaboration with Virginia's DCR. So we put all the floodplain maps online. So if you are in a floodplain, you do need flood insurance if you have a mortgage. However, the important thing I think about this tool is if you are this person living right outside the floodplain, chances are you will flood. But flood insurance is very cheap because you're not technically in the floodplain. So I encourage people to look into that anyway. The FEMA maps, so the flood insurance maps, are intended for regulatory purposes. They're not actually intended to predict flooding. Okay, so they're intended to decide whether you have to be charged for flood insurance. And so they are retrospective and based on current conditions and historic conditions, okay? They don't look into the future. They have no forward-looking capacity at all. If you want to know what's happening forward-looking, we do have a sea level rise map. It's in that same tool. And you can put on different sea level rise scenarios over here. And then you can step through time. And then if you click on one of these blobs where sea levels come up, it will actually tell you how deep the water will be at different times under that scenario. So this is more of that question of what's going to happen in 20 years. Okay. Yeah, so one of the things I did want to point out is one of the pieces of information we try to work on in terms of policy is things like community rating system is part of the National Flood Insurance Program. And this is a program where if a locality makes good decisions, okay, and does good flood planning, then every policyholder in their county gets a discount. And so we do have links on the website where you can go and you can see your county and you can see both its current rating and what the discount associated with that is. But you can also see the specific steps it's taken. And you can see steps that other counties have taken. And when people ask me what they can do to be involved and engaged, I actually think engaging with your county about the community rating system is one of the best things a individual person can do for their locality, because it helps protect everybody in the locality when the localities take these steps that improve the rating. One of the things we're working on right now in collaboration with the Virginia Department of Transportation is looking at road networks and how they flood and obstruct traffic moving across them. So this is not on AdaptVA yet, but it will be. And so there's two questions that we're answering here. One is this question of, you see where the road's red, okay, so it's flooded. So this is an impassable piece of road. And this is what you need to know if you need to know, okay, where do I need to go to raise my roads, or where should I put in a bridge maybe? And the other question is, which is the inaccessible roads, okay, or inaccessible areas. So this area will not be flooded in 2050, but the road going into that community will be flooded. So even though the community itself will not be flooded, you won't be able to get in and out. You won't be able to get emergency services in and out. So this is important for the land use planning piece of it in a locality. And this is important information. We do produce maps that are throughout the entire state. We're producing them, we're working on it, that map out these areas that are going to be underwater, whether there's a development there or not. And so these are important when we're looking to reduce future impacts, is that we don't go in and develop areas that will be inaccessible in 2050. We have these story maps up there under the adaptations, and these have a lot of different building modifications, or they have storm surge barriers, they have levees. The thing that's important about them to me is that they talk about what the technique is. So this is one for elevating houses. But they also put project costs there. So that's important. So you can look around and see kind of what different projects are going to cost you. And then also, what are some people who will partner funding wise to help reduce the burden of that? In Virginia, most of our adaptations at this time are done by individuals. And so the burden, the financial burden of adapting is on the individual. And so this is, of course, means that the resilience of the community is only as strong as its pocketbook, right? So there is a lot of efforts to see how we can change that model and to see how we can sort of share the resources that are available. So FEMA does help raise houses, elevate them. HUD's been doing some buyouts, some community buyouts, that kind of thing. But this is still an area where there's a lot of work going on. Okay, and I'm just gonna show you, this is just for fun because this is ours, this is our building at VIMS. But if you see right down here, it was, there was a building here before, this is a new one. You can see it's like right on the waterfront. And the original building was destroyed during a storm flood event. So we rebuilt, and this is not it's a slightly elevated structure, okay? So we filled this area to bring it up to 6 feet above sea level. And then there's a 3-foot crawl space, okay? So the foundation floor, or the first floor is at 9 feet above mean sea level. But this is what we call floodable architecture. So what it is there's a waterproof envelope that protects the building up to 14 feet. And if you can see, the doors are almost like ship doors. Okay, so they actually seal and keep the water out. And all the electrical outlets come from the ceiling so that if water did get in, the electrical systems aren't ruined. And so we have tested this, and we actually got no water in the building. It works really well. So this is just kind of a fun, different flood adaptation technique. Okay, so now I'm gonna stop sharing and we're gonna go into a question answer period.
But
Okay.
if you have questions for Molly, please just go ahead and type them in your chat box, and I am going to read those to Molly so she can answer them. But somebody said it was a really great presentation. Do you ever give this talk to high school groups?
I do give this to high school groups, and I mean, I give it to a lot of different groups. So we do give it to high school, and we do it to a lot of community groups and that kind of thing. So just getting the word out there and getting groups educated is really part of our goal.
Okay, yeah, and we can schedule, you'll get in your follow-up email information about how you can email programs at vims.edu, and we can schedule people to talk to high school groups, one of them being Molly and others as well. So another question is, did you see an impact on carbon emissions during the COVID travel slowdown?
Yeah, so that's a really good question. There was an impact on carbon emissions. They did decline, but it only lasted about a month and a half before they started to pick back up again. So the effect hasn't been long lasting enough to affect global climate, and ocean temperatures are actually lag several years behind air temperature changes. The ocean changes temperature much more slowly. So you'd need a really long shift in carbon emissions to affect the ocean temperature.
Okay. And then, so somebody mentioned that VIMS, the VIMS adapted building is really cool. Do you have any idea on cost per square foot to build something like that?
I don't know off the top of my head, but if you go to the AdaptVA site, to the adaptations, that building is one of the story maps, and it does have the cost per square foot for that.
Okay, great. So we can send that link out to people too afterwards. And then somebody said, if we went carbon neutral tomorrow, has anyone considered how long it would take to reestablish the glaciers?
Yeah, so there has been work on this. So the problem with the glaciers is that they are heading towards a cycle of breakdown. And the best way I can explain this is if you think about the glaciers used to be like a bourbon ball, right? So you put bourbon balls in your bourbon so that it melts really slowly and it doesn't water down your bourbon. You don't put crushed ice in your bourbon because crushed ice melts really fast because you have this really big surface area on the ice. And so what's happened is as the glaciers have melted, they've also split and fragmented. And so now part of why they're melting faster is actually because they have more surface area exposed to the air temperature. So part of reversing it is you have to go back. You have to go more back than you started from, if that makes sense, to overcome that. So I did read an interesting article. I don't know where this is going to go, but where they were trying to put glass beads out on glaciers to try and increase the reflectance of those glaciers, which would, keep them from warming from the sun as much. And so trying to grow the glaciers back. Yeah, so I would say, even if we go carbon neutral, it will be several years before we see really any impact, and probably a lot longer before we see an increase.
Well, I think that seems to be kind of the end of the question. So Molly, I know you have one final slide if you want to put up real quick that just lets people know how they can further connect with VIMS, and then Val is going to wrap things up.
Yeah, so I'm just going to move through. Click on the slide. Okay. We're not going to bother doing these right now, but things to go back and think about is, as people are paying for sea level rise, who should be paying for it? The people on the coast or the waterfront localities, or if this is a federal problem, we all need to pay for. and then what the priorities really should be in our adaptation. So those are just things to think about. And then this is how you can connect with VIMS. And you can connect through social media, or you can get our newsletter. And we love to stay in touch with people. And I should also offer, we will send out the AdaptVA. My email is molly@vims.edu. And I'm always happy to get emails from people and to answer questions. Thank you.
Wow, wow. Round of applause for Molly. Thank you so much to Molly and to the questions that helped illuminate some of what Molly was sharing. Molly, I have to say, this is a topic of importance to me, but I have never heard such an accessible presentation that I could fully understand and really take in not only what's happening, but some things that I could do to make a difference. And I have a feeling that our others who are listening feel the same way. So thank you so much. And I thank everyone for participating and wish everyone a great night. And most importantly, wish everyone to stay well. Stay well for sure. Everyone have a great night. Thank you.
Thank you.